and important formulas discussion. Okay, doubts and formula discussion session for mechanics. Okay, so come on everyone. Now it's a regular time of 5 p.m. So every one of you should be live. Okay, so hello Vikas Kumar, Pawan Kalyan, great. Okay, so how are you all? Come on everyone, come live with us fast. Come on. Come on, what happened? Okay, hi, yes. And good evening to all once again. This is your formula discussion and doubt session for your engineering mechanics. Okay, so if you have any doubt, you can ask. Okay, class very helpful, great, great. So that is basically what our motive is. Okay, what our motive is that this course, this free YouTube course or the paid course which you have already taken, if any one of you have done that, so that should be helpful for all of you because that is our purpose, that is why we are all doing all this. Okay, so today will be the important formulas discussion. So I will be taking some important formulas from the subject of engineering mechanics. Okay, so let us begin, and in between if you have any doubt, you can ask that. Okay, if you have any doubt, you can ask that as well. Okay, now let us begin this. I will just take some important formulas from this whole subject of engineering mechanics. Okay, so let us begin with the first topic itself, that is your resolution of forces. Okay, types of forces. In types of forces we have studied this, that is your resolution of forces. Okay, it is very simple. If you have such a system of a coordinate system and there are forces going like this, though I have discussed it in the first class as well in the types of forces and laws, but again I am just repeating. Okay. Okay, the paid course fees is 7950. The paid course fees is 7950. You can find the link in the description and from there you can purchase the course if you are really interested in that. Okay, so this is theta 1, this is theta 2. So you have the forces on this side as F1 cos theta 1 plus F2 cos theta 2. Okay, this is your resolution of forces I am telling you. This is F1 sin theta 1 and this one is F2 sin theta 2. Clear? So you have the summation of forces in the horizontal direction given as F1 cos theta 1 plus F2 cos theta 2. Clear? And then you have the summation of forces in the vertical direction as F1 sin theta 1 plus F2 sin theta 2. This is very much clear to everyone. Then you can find out the resultant of them using this formula, that is summation of forces in the horizontal direction is square plus summation of forces in the vertical direction is square. Clear? This is how the resolution of forces work. Is this clear? The second thing is, we know one important law that we discussed in this, that was a parallelogram law for forces, for finding out the resultant. There we have, if there are two forces like this, if there are two forces P1 and P2, okay, so they are resultant and they are separated or they are at an angle of theta, so their resultant is given by, this is their resultant, that is the diagonal, and it is given by R is equal to P1 square plus P2 square plus 2P1 P2 cos theta. Clear? 2P1 P2 cos theta. Yes or no? Correct? Okay. Author of SOM best for GATE and SSC JE. See, basically there are for SOM there are many books. Okay. You can go for one book is there by Ramamurtham, very good book. Okay, Timoshenko and Gare is also very good. Then you have Beer and Johnson, that is also a very good book. Okay, so you can try them online. Most of the books are available online. Okay, so you can go through their soft copies and then make it out yourself that which book is good for you. Okay, so now if this resultant is inclined at an angle of alpha from this, that is from the force P1, then this tan alpha is given by basically this force. This one will be P1, this is P2 sin P1 sin theta divided by P1 plus P2 cos alpha. So by this you can find out the angle at which your resultant lies with the horizontal axis or with the force P2. Okay, this is very important. This resolution of forces is also very important. Okay, clear everyone? Now moving on ahead from this chapter, that is your types of forces and laws. These are the basic formulas which are very much important. Clear? Now we come to the next topic, that is your laws of motion. From this, the very important formula is of Newton's second law of motion. Okay, Newton's second law of motion, or the formula for Newton's second law, this is given by F is equal to ma. Clear? Where this F is your applied force, or you can say that F is the cause and acceleration is its effect. Okay, acceleration is its effect. So for a body, or you can say on a body M, if you require to produce an acceleration of A, so the force that is required will be equal to mass into acceleration. But don't call this as force. This mass M into A is not force. Okay, this is not force. This is mass into acceleration only. Okay, this is mass into acceleration only. Clear? Please remember this. This is not force. Because if it is, 4 is equal to 2 into 2. So you cannot call this as 4. This is 2 into 2 only. This is basically numerically equal to 4, but this is 2 into 2 only. Similarly, F is equal to ma, where your m into a is not force. It is mass into acceleration and it is numerically equal to force. Okay, so whenever somebody asks you the definition of Newton's second law, always say that if suppose there is a body of mass m and we need to produce, or we need to have the acceleration of that body as m, as a, then we need to apply the force that is equal to F, and F that will be numerically equal to mass into acceleration. Clear? Because acceleration is the effect and force is the cause. You have to remember it in this way, that force is the cause and acceleration is the effect. So unless and until you apply the force, the acceleration won't occur on the body. Clear? Everyone? Yes or no? Tell me, is this clear? See, Varignon's theorem is about moments. Okay, Varignon's theorem is about moments. It says, okay, I will take that Varignon's theorem as well if you want. Varignon's theorem. Varignon's theorem says, if suppose this is a beam, okay, of length L, and there are suppose two moments that are being acted on it like this, that is P1 and P2. Clear? So it says the sum of individual moments of, or you can say the sum of moments of individual forces about this point will be algebraically equal to the moment of these forces, or basically you can say the moment of the resultant of these forces about the same point. Clear? If suppose these are two forces, okay, and their resultant is like this. Suppose this is their resultant, that is P3, where P3 is the resultant of P1 and P2. So if you find out the moment about this, moment of P3 about this point, say O, will be equal to the moment of these individual forces about O. Clear? CBT1 result, most probably July 15, before July 15. So Varignon's theorem is clear? Varignon's theorem clear, everyone? Somebody asked me, Korra Naresh Chauhan, clear? Varignon's theorem. Second law, determine force not define. Yes. Basically, the force which, the law which defines force is Newton's first law. Newton's first law, not the second law. Okay? Clear? Great. So let us rub this out. So Newton's second law is clear. Now we will see what is a D'Alembert principle. MA is equal to force. It is numerically equal to force, but you cannot call M into A as force. Okay, M into A is numerically equal to force, but it cannot be called as force. Okay, got it? M into A is numerically equal to force, but it can't be called force. That is mass into acceleration only. Clear? Now, important D'Alembert's principle. What does D'Alembert's principle said? From the second law only, F equal to ma is second law. He wrote F is plus F minus ma equal to 0, or he wrote F plus minus ma equal to 0, where this is your external force and this minus of m into a he called as inertia force. Okay, so according to D'Alembert, the sum of external force and inertia force is always equal to 0. Clear? Is this thing clear? What do you mean by D'Alembert principle? D'Alembert principle says F is equal to F plus minus ma is equal to 0, or he said the sum of external force plus inertia force is equal to 0, where inertia force is minus m into a. Okay, minus m into a is your inertia force. Clear? Tell me everyone, is this things clear? Okay, now we have one important one as well in the equilibrium of forces, that is your Lami's theorem. What do you mean by Lami's theorem? If there are any body that is acted upon by three forces, this way, F1, F2 and F3, okay, and the angles are like this, then according to the Lami's theorem you have F1 over sine alpha is equal to F2 over sine beta is equal to F3 over sine gamma. This is your expression for Lami's theorem. Clear everyone? This says if a body is acted upon by force, by three forces, okay, and if the body is in equilibrium, then you have this sort of relation between the three forces, where these are the angles just opposite to these forces. You can see that alpha is the angle opposite to F1, beta is the angle opposite to F2, and gamma is the angle opposite to F3. See, this is second law. This is second law, that mass, if there is a force that is being, Ravindra Kumar, आपका नाम हम ले रहे हैं, I am taking your name, Ravindra Kumar Thakur. Okay, SFD BMD, we will do SFD BMD in the subject of strength of materials. This is the class going for engineering mechanics. Okay, you can see the whole plan. We have this whole plan for the YouTube JE series. Okay, we have the whole plan for this YouTube JE series. We will be taking the subject of strength of materials as well. Basically, after this, your engineering mechanics, from Monday, we will start with thermodynamics, and then will come the subject of strength of materials. There we will see about your SFD and BMD. Okay. Is this thing clear? So basically, according to Newton's second law, Newton said, if there is a force of F being applied on a body of mass m, then the acceleration produced will be equal to a. But D'Alembert said that he deduced this from same things. Okay, he deduced this thing from same thing, that is F is equal to ma. He wrote F minus ma equal to 0, and he just named this force, that is minus m into a, as inertia force, and he said that the sum of external force and inertia force on any body is always equal to 0. Clear? Complete timetable must be given in your description. Okay, complete timetable must be given on your description. You can check it out. Okay. Now let us quickly see about a projectile motion. Okay, quickly see about the projectile motion. What is a projectile motion? What is a projectile motion? Suppose this is any body being projected at any angle u, means at a velocity u, at an angle theta. Okay, so this type of a motion is known as a projectile motion. Okay, and the path which it follows, it's a parabolic path. You can say parabolic path or a parabolic trajectory. Clear? Then what you have, there are basically three things which you need to find out here. One is your height, this maximum height. One is your this, that is your range, and one is the time of flight. Okay. Types of external forces means, types of external forces can be applied anyhow. Okay, it can be a push, it can be a pull, it can be a tensile force, it can be a compressive force. Okay, shear force, all these types of forces are external forces which we apply. Clear? So this is u cos theta this side, this will be u sin theta this side. So what you have, you know the basics of equations, you have the laws of equations like S equal to V equal to U plus AD, S equal to UT plus half AD square, and V square minus U square equal to 2AS. That I am going to write just now. But before that you can see this. For this maximum height we need to find out at this point, you can say at this point, if this is the maximum height, you know at this point only the velocity which will be, that will be only your horizontal velocity. or you can say the vertical velocity will be 0. Okay, you have the vertical velocity equal to 0. So what you can do is v square, you can use this equation, v square minus u square equal to minus 2gh. Why minus g? Because g is going upward. So when we are going upward, we take the g as negative. Okay, and the u initial in this direction is u sine theta. Yes or no? Yes or no? Okay, and the final velocity in the vertical direction will be equal to 0. Okay, so we write it 0 minus, this is your initial velocity, u square sine square theta minus 2gh. Okay, so from here we get this minus and minus goes off, we get h, that is the maximum height, is equal to u square sine square theta divided by 2g. Clear? Parallel axis theorem and perpendicular axis theorem, I am coming to that. Please wait, I am coming to that. Okay, so this is it, h equal to u square sine square theta over 2g. Then we have your total time. So total time will be equal to, the distance cover will be equal to ut plus half at square. Okay, or basically ut plus half gt square. Okay, so in the vertical direction, you can say at this point and between this point, we require the time of flight that is between these 2 points, between the initial position and the final position. Okay, so in the vertical direction, when we are considering, the s will be equal to 0, because at here as well and at here as well, at both the points, your body is at same horizontal level. So s will be equal to 0. So you will have u in the vertical direction is given by u sine theta t minus half g. This will again become minus g. Why? Because I am considering the force in the vertical direction, and when going in the upward direction, this will become minus gt square. Okay, so you have one thing, that from one you can get that t is equal to 0, and from other you will get t is equal to 2u sine theta divided by g. Clear? So this t is equal to 0 is this point, and t is equal to 2u sine theta is your time of flight. Clear? And in the vertical direction, in the horizontal direction, you can see that there is no acceleration that is being working. Okay, only the acceleration that is working in the vertical direction, that is equal to g. So in the horizontal direction, there is no acceleration. So you can simply write your distance covered in this part, that is distance covered, or you can say distance covered in the horizontal direction, that is equal to r, is equal to your velocity, that is u cos theta multiplied by this your time of flight. So this is u cos theta, this is 2u sine theta, so it will become u square 2 sine theta cos theta will become equal to sine 2 theta divided by g. So this is basically your range. So basic 3 formulas which are required for your projectile motion is, one is this, and one is this. This is the total height, the maximum height, this is your time of flight, and this is your range. Clear everyone? Come on. Is this clear everyone? Yes or no? Tell me fast. Is everything going fine? Or any problem? Tell me fast. Tell me, come on. Everyone. Okay. Okay, now coming to your moment of inertia part. Suppose this is the x-axis, this is the y-axis, this is any body A. Okay, and let us take the small area of this body as dA. This body has the distance of y from this axis, x-axis, and the distance of, we take any point here, okay, of this small area dA, this distance is x. So moment of inertia of the body about x-axis will be given by integration of y square dA. Clear? Timing of classes 5 p.m. On Monday, Tuesday, Wednesday you will get the recorded classes, and on Thursday and Friday we are live at 5 p.m. Clear? And Iy will be equal to x square dA. Clear? This is basically Ix, means the moment of inertia of this body about x-axis. This is the moment of inertia of the body about y-axis. Clear? Then, if you will need to find out about z-axis, this is given by Ix plus Iy. This is nothing but, this is only your perpendicular axis theorem. Perpendicular axis theorem. Clear? Parallel axis theorem says, if this is any body having the area A and we need to find out, basically this is the center of this body, okay? So about this body, suppose about this axis, that is the any axis passing through the center of this body, we have, suppose this is IY, okay? And there is any other axis, say any arbitrary axis A, which is parallel to this axis and which is at a distance of r from this, okay? So what will be the moment of inertia of this body about axis A? That will be equal to IY plus, suppose let us write this as B, okay? And A is the area of this body, okay? So this is A into R square, that is the moment of inertia of any body, the moment of inertia of any body about any arbitrary axis will be equal to the moment of inertia of any parallel axis which is passing through the center of that body, that is IY, plus A times of R square, that is A means the area and R square means the square of the distance between these two axes. This is nothing but your parallel axis theorem. Parallel axis theorem. Clear? Parallel axis, perpendicular axis. Clear everyone? Yes or no? Tell me. Tell me fast. Parallel axis theorem, perpendicular axis theorem. Clear? Yes or no? Okay, and this also, that this is the axis, this is the moment of inertia of the body about any axis which is perpendicular to the plane. So this is also known as polar moment of inertia. Please remember, moment of inertia of the body about any axis which is perpendicular to the plane of that body is known as polar moment of inertia. Please remember this. This is very important. Clear? Now we will see for some important bodies like rectangle we have, like rectangle, suppose this is any rectangle having this B, this is H. Suppose this is your x-axis, this is your y-axis. So moment of inertia of this body about x will be equal to 1 by 12 BH cube and y will be about 1 by 12 HB cube. Clear? Yes or no? Okay. Moment of inertia basically denotes or physically basically determines the distribution of the area. Basically we have two moments of inertia. One is your area moment of inertia and second one is your mass moment of inertia. For the plane bodies, for the 2D bodies, they do not have mass. We consider them as massless bodies. So we say that the 2D bodies have only area moment of inertia. Whereas the 3D bodies which have the volume, we say that they have the mass moment of inertia. Okay? So moment of inertia is basically important. It shows the distribution of the mass or distribution of area within the body. Clear? So this is going to be, now if I take any triangle, this H. Okay, so there is two axes because you know for the triangle its centroid does not lie, because in this case of a rectangle, since it's a regular body, so its centroid lies at its geometrical center, whereas in the case of triangle, its centroid does not lie at its geometrical center, it lies at this position, which is at a distance of 2h by 3 from its apex, or you can say h by 3 from its base. Clear? So about this axis if I talk about, Ix dash is given by 1 by 36 BH cube, and using the parallel axis theorem we can find out the moment of inertia of this triangle about this base, that will be given by 1 by 12 BH cube. Clear? These are basically very important. We use them in the subject of strength of materials as well, in the SFD, BMD and all. Okay, so please remember them. Clear? Is it clear everyone? BH cube by 36, yes. BH cube by 36 is about the centroid. About the base it will become 1 by 12 BH cube or BH cube by 12. Clear everyone? Tell me fast. Then I will proceed. I have to take lot many formulas here. Y for triangle is difficult to calculate. Basically, it won't be asked in the examination. In that, what you have to do, you have to take any section, okay, then you have to find out its area, okay, and then you have to find out it's about this axis, and then you have to integrate it from here to here. So leave it. It will not be asked in your JE level examinations. Leave it. Completely ignore the things. Basically, whenever you are preparing for any examination, you must have the idea of the things to study and the things to leave. Because if you talk about the syllabus of engineering mechanics or engineering mechanics subject, okay, the things are very vast. But you all are preparing for RRB JE, SSC, JE level, so you have to know strictly where to start, where to stop. Okay, where to start, where to stop. So basically, that's why I am saying that about the x-axis is only important. Please remember this. About y-axis, z-axis, forget it. Clear? Now we have the mass moment of inertia as well. Mass moment of inertia. If I talk about a disk, a thin disk, okay, I am talking about a thin disk. Thin disk means which is filled like this. It is having the mass m and the radius as r. So its moment of inertia is given by mr square by 2. This is not the gate classes that are going on, okay. And if it is a ring, ring is of this shape. If this is having the area as radius as r, so I will be equal to mr square by 2. Clear? Sorry, mr square. And we have one more thing that is known as your radius of gyration. Radius of gyration. That is simply if we are taking the moment of inertia about x-axis, so that is equal to a kx square, where this becomes your radius of gyration, and we can write this as kx is equal to ix divided by a root. Clear? Inertia is a different thing. Inertia is basically that property of the body by which it resists the change of state. Suppose there is any body which is at rest and you need to bring it to motion. Okay, so you will try to apply some force so that the body comes into motion. But what happens when the property of that body will still tend to be at rest only? So that is basically what Atendra Singh Saini has explained in Hindi, that you can understand it in a better way, I think, because that is a layman language he is talking about. So that is something that when you resist something, okay, some force are being applied onto you, you are asked to do something, but you are basically resisting to do it. That is the similar meaning of, okay, so that is basically the meaning of inertia. Clear? He is explaining it to you in a more layman language, so I think all of you can understand. Okay, now we have the term as, now we come to the motion part, that is your translational motion, kinematics, translational motion. Average speed and all you all know, speed is distance upon time, velocity is displacement upon time. Distance is the overall distance that is covered or overall part traveled by the body, and displacement is the distance, or you can say the difference of the positions between the initial and the final position. That is your displacement and distance. Average speed is, suppose there is a body traveling with a speed of S1 for T1 time, S2 for T2 time, S3 for T3 time, and so on. Okay, so its average speed is given by total distance upon total time taken. So total distance will be equal to what? You know, distance is speed into time. So total distance will be S1 T1 plus S2 T2 plus S3 T3 plus so on, and total time will be T1 plus T2 plus T3 and so on. This is how you get your average speed. And similarly, if you just change this speed into velocity, you will get your average total displacement over total time. That will be your average velocity. Clear? Yes or no? And please remember, distance can be positive only, whereas your displacement can be positive and negative, because displacement is a vector quantity which have both magnitude as well as direction. Clear everyone? Now we move on to some of the equations of translation motion, like V equal to U plus AT, okay, where V is your final velocity, U is initial velocity, A is the acceleration and T is the time. Clear? S is equal to UT plus half AT square. This is the distance traveled. Other meanings have same thing. V square minus U square is equal to 2AS. These are for your linear motion. And if in this linear motion only, this is for basically you can say for the horizontal motion, or these are the general equations for where if we are taking the motion in any inclined plane or any plane, then this acceleration will change in terms of G. Okay. So this is basically you can say the horizontal motion, and if we talk about the vertical motion, we have V equal to U plus GT, S equal to UT plus half GT square, and V square minus U square is equal to 2GH, or basically this will also be H only. Clear? Whereas if we are going upwards, the G is taken as, if there is upward motion, G is taken as negative, and if it is a downward motion, G is taken as positive. Clear? Is it clear everyone? Are these formulas okay everyone? These are for linear motion. These are for linear motion, okay, and if we just convert them to your circular motion, so in circular motion you know that if there is a body, if this is a circle, body is going this way with a angular velocity omega, and in time dt it travels an angle d theta, so you have omega is equal to d theta by dt, where this is your angular speed, okay, and we have angular acceleration that is given by d omega by dt, or it is also given by d2 theta over dt square. Clear? So these changes, these formulas changes, simply your V will be final omega is equal to initial omega plus alpha t. Please remember, this alpha is analogous to A, okay. Theta, the distance traveled, now in a circular motion, theta will be the distance. So theta is equal to omega it plus half alpha t square, and omega final square minus omega initial square is equal to 2 theta 2 alpha theta. So these are for your circular motion. Okay, this is for linear motion, horizontal plane. This is linear motion's vertical plane. This is circular motion. Clear everyone? Tell me fast. Yes or no? And we basically have two more types of acceleration, because when this body is going in this direction at each and every point, please remember the direction of velocity is this or this is the motion of the body, okay. So basically angular acceleration is nothing but angular acceleration is mass into velocity into r, sorry, angular momentum. Angular acceleration, this is your angular acceleration only. I thought that you are asking angular momentum. This is angular acceleration, okay. Then I am telling you the body always tends to go in a tangential direction. So it basically has circular motion in vertical. That is basically a different thing, okay. In that we have to do it using these equations only, okay. That also you can do. Similarly from these equations you can derive those, okay. Atendra Saini, please don't feel offended. Please don't feel offended. I was just saying that you are helping the students in understanding in a better language. Okay, you have given me that which you are giving me a 4 lines of explanation. Okay, that is okay. I understand what inertia is, and I know that you are also understanding what inertia is. Okay, so I am saying that I was appreciating your effort that you are telling the students to understand in a better way. Okay, that way I could have also explained that, but we have the restriction that this course and all is everything is designed in English, so we cannot speak in Hindi here. Okay, I was saying that you are helping the students understand in a better language or in a simpler language, the layman language I said. Okay, you are feeling offended and you are just writing the 4 lines here. So still, instead of doing all this, if it's better that if you follow these classes, these courses, if it is helping you, otherwise you are free to do whatever, whatever other work you have. Okay, clear everyone? Now, that's why we are not speaking in Hindi, because we know that the people are there from South Indian as well. And I also feel that all of you have done your BTech, BE or radial and tangential extension, I'm telling you it. Okay, and all of you have done your BTech and BE from English only. So it is better that we use the English language so that everyone can understand it. Yes. Suppose this is any circular motion. The acceleration this side, this is your tangential acceleration. It is given by alpha into t. Okay, and the acceleration this side is your radial acceleration. This is given by omega square r. Clear? And there will be the resultant of both these, from which you will get the total acceleration. Okay, from this you will get the total acceleration. That is AR is equal to omega square r, AT is equal to alpha into t. Clear? Clear, yes or no? Tell me. Is it okay, everyone? Please don't fight among yourself. It's okay if somebody has said something. Please don't get distracted. Just follow here. So kinematics, translational and rotational motion done. Okay, now we come to kinetics. Kinetics is basically, I already told you, the subdomain of dynamics. The subdomain of dynamics where forces are taken into consideration. So from forces we have an important concept, that is your work. Okay, and work is nothing but, you know, that is force into displacement. If there is any body, this is acting upon by the force F, and it has the displacement say ds in this direction, and this angle is alpha. So your work, that is dw, is given by F cos alpha into ds, the dot product of this. Okay, since force is also a vector and your s, that is your displacement, is also a vector. Okay, force is also a vector, displacement is also a vector, but we are taking a dot product from this. Okay, F cos theta ds, this becomes a dot product. So this becomes your scalar quantity. Please remember, this becomes a scalar quantity. Work is a scalar quantity, it's not a vector quantity. Okay, then we have different kinds of work or energy. So first of all, if there is a motion in the body, so the energy that is possessed by the body by virtue of its motion, that is known as kinetic energy, given by half mv square, where m is the mass and v is the velocity. Clear? The energy possessed by the body due to virtue of its position is given by mgh, that is your potential energy. Clear? See, we have planned this course in such a way that you will get that questions, and also there is in the description you can find one link of one article is posted on our Gradeup app as well. Okay, so from there you can practice 10 questions every day. The quiz is being posted there, and also you will get the weekly quiz of 15 questions tomorrow. I am saying the questions are given in the app. Okay, we have a full plan of this going through in one article. You can just find the link of that article in the description box, and from there you can attempt the quizzes every day. Okay, is it okay, everyone? And if there is a spring that is being pushed, if there is a spring having the spring constant as k, and if it is displaced by a distance x, if the force F is being acted upon this, so it is given by F is equal to kx, and the potential energy, please remember the potential energy, the potential energy will be stored in this form. In the case of a spring, please remember the energy stored in the spring is in the form of, the link is given in the description, please remember. Okay, Don't crack jokes here. We are not here for cracking the jokes. Okay. The energy stored in the spring is in the form of a potential energy. Please remember, and that is given by half kx square, where k is the spring constant and x is the displacement of the spring, or the compression or the extension of the spring due to the applied force F. It is applied in this direction, compression, so it will be a compression. Okay. If it is applied in the forward direction, in the outward direction, then it will be extension. Clear? Yes or no? Okay. This is basically for a linear motion, and if we talk about for a circular motion, this becomes this thing. That is half I omega square, where I is your moment of inertia. This I is for moment of inertia and omega is for, I is moment of inertia and omega is your rotational speed. Okay, or angular velocity you can say. See, for the fees and anything, if you have anything, any doubts, you can call us or you can mail us. Okay, just go to the description. In the description, the link of the course is given. That is the Focus JE Mech course. What you can do, you can just go there. There are the communication details. The email ID and phone number are given for our concerned department. You can call them and discuss whatever issues you all are having. Okay. Regarding the buying and payment of the course, and not about the topics and all. Okay, because they are not going to deal with the subject matter. Now we have one last subtopic which we learned in this, that is your momentum and collision. Momentum and collision. Okay, so momentum and collision is very simple. Momentum is nothing but mass into velocity. You all know this. Okay, and if there are two bodies, m1, m2, moving with a velocity u1, u2, okay, and after collision, they still have the same mass because mass is not going to go anywhere. And after the collision, they are moving with v1, v2. Okay, so law of conservation of momentum says m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This means your initial momentum is equal to final momentum. This law is only known as law of conservation of momentum. Law of conservation of momentum. Law of conservation of momentum. Okay. And there is one more law that is known as law of collision. Newton's law of collision. It says that velocity of separation divided by velocity of approach, velocity of separation, velocity of approach is equal to E. And this E is only known as your coefficient of restitution. Coefficient of restitution. Okay. Velocity of separation. This is the velocity of separation. Please look into one thing. These bodies will collide only and only when u1 is greater than u2. Yes or no? And these bodies will separate only if v2 is greater than v1. This is the condition for the collision to take place. Okay. So velocity of separation, that means v2 minus v1 over velocity of approach, that is u1 minus u2 is equal to E. And this E is equal to 1 for perfectly elastic collision. For perfectly elastic collision. Perfectly elastic collision. E equal to 0 for plastic collision. Or you can say it is not called plastic though. It is called perfectly inelastic or inelastic collision. Or you can say perfectly inelastic collision. Inelastic collision. This has the value of 0. And the value of E lies between 0 to 1. It is simply called as inelastic collision. Clear? 0 to 1 is inelastic collision. Clear? Then in the case of elastic collision, your momentum as well as kinetic energy both remains constant. But if it is an inelastic collision, then there is a loss of kinetic energy. Your law of conservation of momentum always remains constant. Please remember whether it is elastic or inelastic. But in the case of kinetic energy, the kinetic energy remains constant only in the case of perfectly elastic collision. Other time there is loss in energy, and that is given by m1 m2 over twice of m1 plus m2 into u1 minus u2 whole square into 1 minus E square. This is the general formula. You can yourself put E equal to 1 here, this whole term will become 0. So for the elastic collision, that is perfectly elastic collision, your loss in kinetic energy will be equal to 0. Okay? Clear? So that's all for the day. I hope you learned something out of this session. Yes or no? Was this session helpful? Everyone, please tell me. We have come to the end of this. Okay? Or basically I can say that we have come to the end of this subject of engineering mechanics for this YouTube series. Okay? So if you found this useful, if you want to study the engineering mechanics from me for this subject, for this exam of RRB JE or SSC JE, what you can do is, you can go to the link. There is the link that is for the course of Focus JE Mech course. Okay, it is available. The full course, I will give you around 15 classes there. Okay, more than 15 classes are there. Okay, timing of class is 5 p.m. Thursday and Friday. And on Monday, Tuesday, Wednesday, you get the lecture classes that are in the recorded, and that too is at the 5 p.m. only. Okay, so what you can do is, if you want to study the whole subject of engineering mechanics and also the SOM and other subjects from me, okay, so what you can do is, you can go to the description below. There is the link of this course, that is Focus Mech JE course. So there we will come together and we will study this subject in a greater detail. Okay, so thank you all of you. Prepare well for your CBT2 examination, and also you will be having the course. There will be a course that is given. Basically, I am saying that there is a article that is posted on a Gradeup app. Okay, article that is posted on a Gradeup app. You can go there. You can find that link of the description. There you will get the weekly quiz from the subject of engineering mechanics. So prepare well for that. Okay, and do one thing. Prepare well for that and come prepared on Monday for the class of theory engineering mechanics with Vikas sir. Okay, so thank you. See you there. In the strength of materials will come after engineering thermodynamics. Basic thermodynamics will be there. Okay, after that we will come with the strength of materials. Okay, I will be coming up with you all in the next subject of strength of materials after we cover up with the subject of thermodynamics. Okay, so prepare well with Gradeup. So okay, so thank you and have a nice day.